When you go out and talk to the general public, right, they think the poultry industry is this archaic thing. They don't realize the amount of advanced science and technology that goes into every aspect of poultry production. They go to Kroger and they buy their chicken breast, and they don't think about all of the work that went into getting it there.
Welcome to Unplugged, the official podcast of the Poultry Science Association. This is the podcast where we strip away the fluff and get real about poultry science from bench to barn. I'm your host, Andy Vance, Executive Director of the Poultry Science Association. In this episode, we're going to tackle smart farms and fowl tech, the future of poultry automation. We'll discuss the integration of robotics in poultry farming and the implications for efficiency and animal welfare. Joining us, Colin Usher, a robotics systems and technology branch head and senior research scientist at Georgia Tech University. Colin studied systems engineering at Southern Polytech University and also computer science at the University of Georgia. His research expertise is in perception, robotics, and systems integration. He's been at Georgia Tech for 24 years and works alongside PSA treasurer Dr. Doug Britton, one of my favorite poultry scientists, where they work with several multidisciplinary teams in developing and evaluating industrial automation prototype systems for a variety of clients in the food and agribusiness space. Colin, let's get right into this topic of automation in poultry and all of the different potential applications of robotics. How do you describe in 30 seconds what it is you're doing related to poultry at Georgia Tech?
Well, first of all, thank you very much for having us here, Andy. I really enjoy to talk about the research and the things that we do. The 30-second elevator pitch would be that we like looking at novel automation techniques and opportunities where we can apply advanced technologies and engineering sciences into poultry processing and production and see where it fits and what makes the most sense.
I want to look at some of the specific applications. I think everybody has some exposure to things like drones, or, in our house, we have a robot that goes around and vacuums at a set time every day. What are the applications of those kinds of technologies in a poultry house? What's happening today currently? And then, where is that technology going? The possibilities that you're exploring.
Today, if we look at it, right, the robotics applications inside poultry houses themselves are a little bit in their infancy. There are a couple of companies that have made some stabs. There have been some shifting around recently in the companies. We have been working a long time on a robot-enabled application in commercial farms. Back in 2014, when we started this, you talk about what are some of the things that they can do. We really started tinkering with robots in houses, and we approached it from, okay, the first thing, maybe we would treat this as a mobile sensor platform. It would move through the house, characterize things on the flock, such as uniformity of the flock, the growth rate, animal welfare type of information for it, basically collecting data as it moved throughout the flock. And when we took this to farmers and talked to them, a lot of them said, wow, this is really cool, but, I'm going in the houses and I've got to do things. I've got to remove mortality. I've got to pick up floor eggs. And when I'm doing this, I'm in there qualitatively assessing my flock, looking at the equipment. Why do I need to pay extra for something to run around and tell me what I'm going to find out anyway when I have to go in the house? We really started exploring what are the applications that are beyond just sensing. What utilitarian things can these robots do? We looked at, you heard me say mortality picking and egg picking. We actually approached both of those. We've really developed a robust system and robot for picking up those floor eggs now. We've also looked at some of the mortality removal. I'd say it's not as robust as the egg removal at this point, but these are actions that the robot can do for us. As we see, one of the big benefits is reducing or eliminating the need for people to go into these flocks.
I want to pick that apart for a minute, Colin, because I think you've described a couple of applications that make sense to me. Like I mentioned, we've got a robot vacuum in our house here. So I'm picturing, the floor egg thing is like the Roomba for floor eggs. I don't know if that's right or not, but that's what my mind thinks of. But when you're talking about the sensor platform and going in and collecting all that data, those first stabs, I'm picturing like R2-D2 rolling through a broiler house. My question for you is, what is it that robots do well, where you'd say, oh man, this is the kind of application where it makes sense to use a robot versus a person? And what are the applications where you say, well, a robot could do that, but maybe it's still better for a human being to go do it. Wait, maybe walk through the things that robots do well, usefully, efficiently, sustainably.
You said something I've said many times. I say this is a chicken house Roomba, right? It runs around and cleans up the floor for you. Like a Roomba, right? This is something that can carry out mundane tasks, but it can do them every day. You want your Roomba to vacuum your house 4 times a day, you schedule it and it does it,
Sure.
right? You don't want to go and vacuum your house 4 times a day. So
Nope.
egg picking, for example, is very much like that. When a hen lays an egg on the floor, other hens see that egg and they say, "Oh, that's a nest. I'm going to lay an egg on the floor too." So it's
Okay.
very important to regularly remove the floor eggs throughout the entire day. But that makes no sense for a paid laborer whose job just to stand in a house all light hours of the day and pick eggs up off the floor. So that's naturally a very good application for an automated system to do. Things that need to happen all day long are things that adapt well to these types of systems.
Yeah, is it fair to say so routine, repetitive, low cognitive, they're routine. In other words, I don't have to think through, oh, the chicken did this, so I need to do, something out of the ordinary. That is that maybe where we see, okay, if it's repetitive, same things over and over again, it doesn't take a lot of high level brain power, so to speak, to do it. The robot can do those kind of tasks maybe more efficiently than the human.
That is one aspect of the application. But on the other side of that, there are actually applications that you can do via machine learning techniques and sensing techniques where you can gather data more robustly, perhaps, than a human can. In a lot of cases, people are doing qualitative
Mhm.
assessment of their flocks. Right, they're walking in and smelling the air and listening to the birds. Well, we have opportunities to take quantitative information from those birds, so we can get, for example, 3D profiles of them, and we can look at the uniformity of the flock, and we can generate that bell curve of what that flock might look like. Right, this is information that might be valuable when it comes time for processing or deciding what is the best end result for that flock.
And I'm picturing a few different areas of technology kind of having to come together at once, like what the actual robotics themselves are, what I'm thinking of, like the mechanical aspect of the robot being able to move around and interact and so on and so forth. I'm thinking about the sensors and the other, probes and data collection interfaces, if you will, but then also that software of the machine learning, big data, et cetera, et cetera, et cetera. Where are we in the development of all of those kind of those three different areas? And maybe there's some that I'm missing that have to work in concert for the robots to really, or the automation to really return a high level on the investment that would go into making them for a farm or a barn manager.
Yeah, that's one of the fun things I think about my job is the fast pace of advancement in both hardware and software and algorithms and capabilities. The pace just gets faster and faster every year. And what we see, and something I think you didn't quite touch on, but is very important to it, is the lowering threshold of cost of these capabilities. And that's something that's really enabling us to get more advanced applications in these spaces because the cost is coming down. I mean, no chicken farmer is going to buy a robot really, no matter what it does, if it costs them $75,000, $100,000 a house. Right. When you buy a Roomba, it's a couple $100, maybe $1,000 on the high end.
Yeah.
But, no one's gonna go buy a Roomba for $10,000. They're just gonna, grit their teeth and vacuum their house. As that cost drops and, as the capabilities become more advanced, we're able to do more advanced things. The term is on the edge, right?
Mm,
There are a lot of data centers and a lot of cloud compute and things that can do heavy lift when it comes to processing all of that data, but we can push a lot of that down now to the robot, to the edge, so that the system it's thinking and it's sensing and it's producing this data and it's giving you those results all on the unit, right? You don't have to have an internet connection or a cloud service plan or things
mhm.
like that enable the processing. All of this capability means you can do more advanced interactions and things that robot can do. We keep going back to that Roomba analogy, right? Those
Right.
first generation Roombas were blind and they just bump around the walls and randomly
Yep.
cover your space, right? The $1,000 Roombas, well, they've got cameras on them, they've got sensors on them. They now smartly move and zigzag through your living room and optimally vacuum the corners. These are the same analogous things you can talk about the capabilities of robots in a chicken house. Now we can smartly cover the floor area. We can detect that's a chicken, that's an egg. We won't tell you what came first, but we'll tell you which one is which.
When you're looking at where we are and where we're going, so it sounds like the robots being able to deal with floor eggs. I hear you describing it in a way that sounds like, okay, that's a here and now kind of thing. The R2D2 kind of sensor platform thing that we were talking about earlier, like I hear a lot, and maybe it's just because I'm a wannabe data junkie. I hear a lot of promise and application, but maybe walk us through, here are things that are now maybe commercially viable or on the cusp of being commercially viable versus what you're excited about that's coming in the next 2 or 3 years that maybe isn't in a number of houses yet, but you think will be.
I don't know if I could say 2 or 3 years. I might say 5 or 10 in some of these
Yeah,
cases.
sure.
When the here and now, as you mentioned, right? I think we've developed and we're looking to try and commercialize a robot that we say picks up floor eggs, right? And that's really what it does. Now it has these auxiliary sensing functions and things that it does, but I am really excited about what I think is the opportunity of better management through data. If you have a persistent eye in your house and you can characterize that uniformity of your flock, and you can characterize the welfare of that flock. You can automate the gate scoring, for example.
Hmm.
There are several applications and opportunities that I think are very hard to quantify what the payback is until you get these systems out in the field and you start learning what the benefit you have and what data is valuable and what isn't, right? I can give you heat maps all day long of your house, but it doesn't matter unless I can help you make a decision. Turn a light off here, you'll have less floor eggs.
Hmm.
Something along those lines. And I think as we start seeing more of these systems in the houses, we're going to see more interesting applications or uses of the data that are more actionable and allow you to better manage that flock, better optimize that growth, bring enrichment into the house. How might you interact and keep the birds generally happier in a sense? I also think there's an interesting avenue of how might you change the design of modern houses or those future houses to better enable automation. An example I give is if you do want a robot running around on the floor, maybe the feeders and the feeder pans might in sections automatically raise themselves up. So the robot has free roam under that area to clean the floor area, smooth out the bedding, carry out other management functions. And then as it moves into the next section, it just lowers back down. This would, in effect, kind of move chickens out of the way, giving the robot free reign of the floor so it could do more interesting value-added activities. And that goes not just robots automation, but how might you better automate smart drinkers and feeders that tell you when they're leaking or
Right.
tell you when the feeder is jammed or, control the feeding optimally for the birds spread through the house. There's a lot of interesting work in that area that I think we're going to see more and more of as you look at incremental steps of optimizing that flock growth.
Well, I'm thinking about the ways those different technological advances work in harmony and concert. You just described it well. The automation of your feeding and drinker systems, ventilation, and then layering on this idea of the robotics that might be actually interacting with the birds or moving about the barn to sense the environment. All those systems, in theory, can work in concert and influence one another. One of the questions I've got for you is thinking about how this comes together from a research standpoint, a scientific development standpoint. What's that process like for you and your colleagues at Georgia Tech? Do you talk with a producer in a barn and say, hey, what's keeping you up at night? And then take those things back to the lab and say, okay, how can we pick this apart? Or are you're sitting at home watching your Roomba vacuum the floor and you say, wonder if we could do that with eggs. Like, what's that discovery process look like for someone in your space?
I'd say it's a mix of some of those, but I would be remiss without saying that we have a wonderful state program here in the Agricultural Technology Research Program. It's a state funded program that the poultry industry formed 51 years ago now at this point to allow engineers to help keep the poultry industry state of the art and really attract high level knowledge and people to Georgia to work in the industry and keep the poultry industry strong in the state of Georgia. We have an advisory council that comes once a year and meets with us, and we present our current research projects. We talk about what are their challenges now, what are their challenges, what do they see 5 years down the road, what do they see 10 years down the road, and they really steer our direction of research. Our group is much bigger than just robotics. I'm just one small project of about a dozen or so projects that are going on in this field. All of these are really steered by that committee, but we also regularly visit farms. We regularly visit processors, and we talk with the people on the floor, and we talk with the management, and we try to really capture what are those really challenging areas, where are you hurting the most, and how might automation and science be applied in those areas to better those processes.
And then when you get, an idea, let's take the floor egg robot as an example, and you say, "Hey, we've got proof of concept here. We've hashed this out," and you get it out in a barn. I'm assuming that there's a bit of a feedback process that happens there where, producers saying, "Hey, Colin, this is neat and everything, but here's the problem," whether it's cost, whether it kept bumping into the chickens, or, some practical things. What do you see as the barriers, the roadblocks, or the bottlenecks to seeing more of these innovations at commercial scale or adopted regularly? Is it, hey, we're not there yet necessarily with some of the technologies, the actual operation of whether it's the software or the hardware, or is it cost, we're still not there at scale, or do you run into cultural pushback that the producer's like, "Yeah, I'm just still happy walking barns with my birds because I got to do it anyway"?
So we surprisingly haven't really had pushback in that sense. Like, people have been very interested in the robot. A lot of farmers are like, "Ooh, when can I get one? Right. Is it available? We buy one now." And as a research institution, we're not building robots. We're not producing and selling them commercially. We're trying to commercialize this platform and find a partner to take it. And I would say cost is still a bit of a challenge. These aren't cheap systems. Now, we look very carefully at how you balance cost versus performance to try to maximize that payback. But
Mhm.
it's also very challenging because these aren't out in the fields, and you can't concretely say, this is the payback you're going to get from this system. It's not a automated deboning system where you can say, this one's 5% faster than the other. This one has 10% better yield characteristics than another. So you can easily quantify the payback on those systems. This is a very challenging area to convince people to take that risk to get into. Now, we think the opportunity is huge, but until we can get in there and really prove it, you've got to figure out, how do you get those first ones out there? And as we move from research to commercialization, it's always a challenge. There is engineering work that needs to be done, redesign of the robot chassis itself to optimize it, maybe whether it's injection molded or what the components are to seal it and protect it. Ammonia is prevalent in these environments, and electronics hates that. So how do you properly protect the robot to make it last a long time? How do you keep it clean? These types of things that need to be investments put into that take it from late stage prototype to a commercial product. Getting that investment can be challenging.
Well, and I'm also wondering too about the actual supply chains involved. This is a very interesting time in technology where you're seeing some manufacturers bringing chip manufacture back to the U.S. I live in Columbus, Ohio, and there's a major Intel project that's supposed to be happening not far from where I live, and so I'm wondering from your standpoint what the supply chain looks like. Is that is more of those applications potentially move back stateside? Is there potential there where that slows down the process because cost will be an issue? Or do you look and say, "Hey, man, I think there are going to be great opportunities because we had supply chain disruptions during COVID because all of these components were coming from overseas"? How does that factor into the work that you're doing in thinking about where these pieces and parts come from and how we get them to commercial scale?
I think personally, as we look at what's happening in the United States with manufacturing these types of things, it is going to, in the long run, be a good thing because it's going to bring some of that capability back to allow us to build more and faster systems and innovate more in that technological sector. So take, for example, Shenzhen in China, right? They have amazing abilities to roll out new robotics and projects. If you look at all of the humanoid robots that they're coming out with now that start at $16,000, these things a few years ago were 100,000 plus, if not
Mm,
multiple hundreds of thousands, right? I'm going to buy a humanoid or a Lamborghini, take your choice, right? And I think that, as we bring that capability back into the States, it's still probably going to be more expensive, but we're going to see a lot more opportunity of innovation. I'll also say that the robot chassis that we're using in our experiments now, and all of that is
mhm.
actually from a company from, I believe, South Carolina. So, it is already stateside, and that capability is already here. As we talk about mass manufacturing and things like that, there may be some room for growth in that space. But
Right.
I see more and more opportunity as we bring that type of operation stateside and that types of capabilities. But I do hope that, we still maintain international cooperation and get products from the right spaces and all, share technology.
A rising tide, lifts all boats kind of thing. Yeah, absolutely. And I want to talk about the processing side of things because I've seen some presentations that you and your colleagues at Georgia Tech have done on work you're doing. Obviously, we've been talking a lot about the actual houses themselves, layers and broilers and so on. But when you get
Mhm.
that broiler into the processing side, you're doing some really cool things. So describe what you and your colleagues are doing there to help make the processing end of the food chain more efficient and modern and so on.
Yeah, well, thank you for the good words there. Historically, we actually did more automation and work in processing. It really wasn't until this robot in the houses that we first got into the grow outside or really outside of processing plants. So we have a pretty long history looking at applications in processing, and a lot of that involves robot arms carrying out complicated tasks like deboning. We have a
Mm,
big project looking at doing the shoulder cut debone and trying to match human performance. Adapt really, we call it processing on a lot of one. So we
mhm,
focused a lot at, instead of having a giant piece of equipment and a bunch of cranks and handles where you just adjust that equipment to fit the bell curve, how can you characterize that individual chicken and optimize the mechanization to operate on that chicken for that chicken? So we've spent a lot of effort in this space. Some of the challenges you talked about, the virtual reality system, and
mm,
the goal with that is twofold. One is a lot of these environments are really unattractive environments, right? It's 40 degrees. All right.
yep,
If people are doing deboning, they're doing a repetitive cut on one bird every 2 seconds for hours and hours. They've got to
mm,
wear mesh gloves so they don't cut themselves. They've got sharp knives, right? They're dangerous environments, prone to repetitive motion injuries. And frankly, the retention rate in these jobs is atrocious. So, how might you make this job more attractive? One of our thoughts is that you could put a robot on the line to do that task, but the problem is they're not accurate enough yet. They're not good
mhm,
enough to make that decision on every single chicken and do an optimal operation on it. So our thought was, well, let's put the human in the loop to let them make the decision for the robot. But let's take them out of the environment so they can be sitting in an air conditioned office somewhere, wearing a virtual reality headset and present to them that workspace or that chicken that they need to operate on in 3D. It's sitting on a table in front of you, right? It's all there. So it's a very natural interface that allows people to make quick, high fidelity decisions,
mhm,
and then we can allow them to make the decisions for the robot when it's not able to make the decision for itself. So, for example, we're doing cone loading, and you have a,
yep,
a big pen with a pile of chickens. That's a very challenging application for a computer to take a picture and say, I want to pick up chicken X on the top and put it on the
yep.
cone. A human looks at it and goes, this is easy. I'm going to just pick it up, move it, right?
Yeah,
So,
don't even think about it.
uh,
You just do it.
that's exactly right. You almost don't even think about it. You just do it. We've given the human the capability to tell the robot, oh, pick this chicken up. Okay, pick that chicken up. There's the next one. There's the next one. There's the next one. And as fast as they can point and click, that robot is out in an operation loading those cones. We did cone loading, frankly, because it's a bit of an easier application to get inroads into it and to prove the efficacy of such technology.
Mhm,
But, imagine live hang, right? These environments that are extremely difficult to work in and
yeah,
extremely difficult to have automated sensing in. Well, put a human in the loop, get them out of that environment. But that also adds another layer. They can do this over the internet. They don't need to be in an office in a cold place. They can be in their living room. You think about the gig economy, right? Like
Yeah.
if you have a car, you can sign up for Uber and go taxi people around, right? Imagine the opportunity for I just want to work 30 minutes.
Mm.
I'm sitting on my couch. I can log into a website and find a processing application and I can, load chickens for a while and make a little bit of money.
Well, yeah, I'm picturing like Amazon's Mechanical Turk for, chicken processing. It's kind of a wild concept.
It's a challenge that you'd have to have critical mass before you could probably get to that gig economy approach for it. So you've got to
Yeah,
figure out
sure.
how to phase this technology in and make it feasible and make it attractive. I will say a very big challenge right now. So, for example, the cone loading application, when we've talked to producers, they're very interested in it. But then they're like, but wait a second, I've got to buy a robot to put on my line, and
Mhm.
I still have to have people doing the job. So I've just spent more money and I haven't offset, anything with labor or anything like that,
Mhm.
right? But one of our thoughts is twofold, right? The payback might be in now you have a more willing and able labor pool that you're not having these turnover issues, or you're not a cone loader now, you're a robot operator, right?
Yeah.
Just the semantics of it makes it a more attractive job proposition for people. Someone calls in sick at a plant in Alabama. Well, they call up the plant in Florida and the guy hops on his head and he's operating the system in Alabama, right? And
Right.
and doesn't have to be local with that operation going on. I always laugh at this, right? Because we say that the word AI means something different to us than it does to the poultry industry when we talk about artificial intelligence. But
Mhm.
with such systems, we are looking at, can you then teach the robot to do a better job by itself of doing so for cone loading, for example? A person is in there doing that task, telling the robot, here's a chicken, here's a chicken, here's a chicken, here's a chicken. The robot has the sensor data. It has a success metric, which is whether that chicken actually made it on the cone or not.
Mhm.
And you can
Mhm.
crowdsource that data and train an artificial intelligence algorithm. And now the robot starts doing it
Mm.
and it can improve. And this is something we are researching right now, so I can't say it's done and it's working. This is a working theory, is that you can gradually teach that robot to do the task, and at some point it will plateau. It might never get better than 80% or 90%, but it can do the task 90% of the time. And then when it sees that scene that it doesn't know where a chicken is to pick up, it calls a person.
Wow.
Now you can gradually reduce the number of people per robots that are operating. So you theoretically could have one person operating teams of robots now,
Sure.
and filling in that missing piece for them.
Is the bottleneck there when you're talking about, the like we were talking about the shoulder cut, for example, as an example, if we get, let's say we get past cone loading and move into actually making some of those more challenging cuts, is the bottleneck, hey, we need better sensors, hey, we need more precise robotic armatures? Is it that artificial intelligence component, that it's the actual cognitive process, if you will, that is the holdup of the bird being able to accurately make those cuts?
It's actually a combination of a lot of those things. So,
Mm.
for example, your 3D sensor that is giving you this information has some inherent noise in the data that is coming in. So, if you're trying to make really high fidelity decisions on that data, well, you've got noisy data, so you're only going to be as good as the noise is. And if you need to make a 2 millimeter decision and your noise is 3 millimeters, you're never going to converge on that decision that you need to make. That's a good example of where you might need better sensors for it. Another one is the algorithms themselves, right? There's a giant shift from what has traditionally been called convolutional neural networks. These new technologies and algorithms are opening up new opportunities and providing better fidelity and accuracy on certain problems. Now they don't solve everything, right? But they solve certain problems well better than others. And utilizing those newer tools and these newer opportunities get you even closer and closer to that target.
It's a fascinating time, and I just am really intrigued to see where it goes. I love watching the demonstration that you guys do with the cone loading and the virtual reality headsets. I remember the first time I saw that was at Watts Chicken Technology Summit, and you have a scientist on stage at like the airport Hilton, and it's operating the robot on your campus downtown, 30 minutes away, and it's just a really powerful illustration of the possibility and potential. So, Colin Usher, thank you for walking us through these really intriguing innovations from barn all the way through the processing side of things. As we finish up our conversation together, each week we like to ask guests a question to kind of set the stage for where we're going in the future, and to learn a little bit more about your experience as a poultry scientist. And the question I have for you, Colin, is what's one misconception about poultry science or the poultry industry that you wish more people understood?
I think one of the biggest misconceptions I see is when you go out and talk to the general public, right? They think the poultry industry is this archaic thing that is, stuck in the 1800s with the entire industry. They don't realize the amount of advanced science and technology that goes into every aspect of poultry production, right? Whether it's the farming or it's the processing or it's feed formulation or it's the genetics and breeding, right? There's amazing, smart people applying the most modern technology and algorithms in every one of these fields. It's really amazing to see the amount of technology that goes into this. And I think that's something the general public doesn't see, right? They go to Kroger and they buy their, boneless, skinless chicken breast in a plastic wrap, and they don't think about all of the work that went into getting it there.
Yeah. How did it get there? It's an incredible answer, Colin. And I love it. Thank you, Colin Usher from Georgia Tech University and the Georgia Tech Research Institute, for a great conversation. Friends, if you enjoyed this episode, I highly encourage you to subscribe to Unplugged wherever you listen to your podcast. And if you enjoyed the conversation, give us a rating as well. It helps others find this podcast and engage in the conversation. Some reminders for members of the Poultry Science Association and others who engage with the science. Our annual meeting is now open for registration. We'll be in Raleigh, North Carolina this July for the annual meeting in North American Scientific Conference of PSA. Early bird registration is open through May 14th, so go register at our best rates now. And, of course, book your hotel room and see all of the fun and exciting events that you can take part at this year's meeting in Raleigh. Also, this October, we'll be debuting the Poultry Science Association's Pacific Rim Scientific Conference. Save the date, October 13th through the 16th in Macau. Going to be a fantastic event, meeting with researchers from around the Pacific Rim. Would encourage you to go there. Great opportunity for cultural transfer and research networking. October 13th through the 16th in Macau, the PSA Pacific Rim Scientific Conference. And you can learn about both of those events and register at poultryscience.org. Coming up next week, Breaking the Shell, how in ovo sexing is transforming poultry farming. We'll talk with Yuval Cinnamon of the Volcani Center in Israel about some really intriguing technology happening there with regard to in ovo sexing. That's coming up next week. Thanks for joining us for Unplugged, the official podcast of the Poultry Science Association. For PSA, I'm Andy Vance.